All right, in this section we're going to be talking about variation. Variation does involve word problems, and I know a lot of you are probably thinking, oh no, not word problems. But these are kind of the best type of word problems to deal with because for the most part they make sense. On some of them you may even be able to figure out what the answer will be without doing the math that it takes to get there. And I'll just caution you from the beginning to make sure that you understand the steps, because when the numbers get messy and the problems get more complicated, you need to be able to get through the steps that it takes to get the answers. Reasoning it out is great, but you've also got to be able to follow the steps. Okay, so what we're looking for here is going to be wording that looks like y varies directly with x, or y is directly proportional to x. So when you see that word directly, you know that it's going to go with this model right here, y equals kx. It means that y is a multiple of x. All right, so we're looking for directly. This is called direct variation. So varies directly or directly proportional to. This k right here is called the constant of proportionality. I'm not going to test you on that, but you'll see it in the homework, so you know what the name of that is. That k is a constant. All right, so let's look at how this works with a somewhat simple example. Let's say that we have y varies directly with x, and we know that y is 10 when x is 5, and we want to know what is y when x is 15. Okay, so this is kind of a basic setup for a problem, a little bit simpler than some of the ones we're going to look at, but this gives you the general idea. So we know that y varies directly with x, that's the wording that we're looking for here. We know that y is 10 when x is 5, and we want to know what is y when x is 15. So again, when you look at this, you could probably either look at the relationship between the x's or look at the relationship between y and x and figure out that y is going to be equal to 30. And that's good if you can do that, but we still need to go through the steps so that when we get to the other ones, we can do them as well. Okay, so there's 3 steps for all of these. The first one is you've got to set up the equation. So we know that y varies directly with x. That's the exact wording that we had above. So we can set up our equation y equals kx. All right, now in order to answer any questions about this, we have to know what k is. So the second step is always going to be to get k. How do we get k? Well, we've got to find an x and a y that go together at the same time so that we can find k. So that's what this next line tells us. Y is equal to 10 when x is equal to 5. That gives us an x and y value that happen at the same time, and we can use that to get k. So let's plug in 10 for y and 5 for x and figure out what k should be. So we divide by 5 on both sides, and we get that k is equal to 2. So now we know that our equation is going to be y is equal to 2x for this problem. All right, so now that we've finished step 2, we have k, we should be able to go back and answer whatever question they're asking of us. So what is y when x is equal to 15? That's step 3. We plug in 15 for x, and we get that y is equal to 30. Okay, and that's what we were expecting from the beginning just by using some common sense and reasoning. Okay, but in general, these are our 3 steps. Set up the equation, use what you know to get k, and then plug in the values that you're looking for. Okay, next we're going to look at inverse variation. Inverse variation is a lot like direct variation, but we're looking for things that vary inversely now. All right, so the wording is going to be y varies inversely with x, or y is inversely proportional to x. So you'll see that word inversely in there somewhere. And the model for that is going to be y is equal to k over x. So instead of k times x, we've got k divided by x. So x is going to go into the denominator. All right, so let's look at an example from the book to see how this one works. The idea is still the same. We still have the same 3 steps. We need to set up our equation, we need to find k, and then we need to answer the question. So let's see if we can do that with a real world problem here. So the rate of vibration of a string under constant tension varies inversely, those are the words we're looking for, with the length of the string. If the string is 48 inches long and vibrates 256 times per second, what is the length of string that vibrates 576 times per second? Okay, so there's a lot of information here. Let's break it down to what we need. We know that we have varies inversely, so we know we're going to have this model. We're not given letters this time. We're not given an X and a Y, so we're going to have to figure out what our variables are and what letter we want to give them. You can use X and Y for everything, but then it gets confusing as to which one's X, which one's Y, so I'd recommend use whatever letter makes sense for the problem. So for this one, we're looking at the vibration varies inversely with the length. Okay, so if we break this first sentence down to what we need, vibration varies inversely with length. Those are the key words right here. All right, so since we're not given letters, let's make up our own letters that make sense. So let's use V for vibration, and yet let's use L for length. So we've got V varies inversely with L. So if we look at our model up here, and we use V and L, we're going to have V equals K over L. V varies inversely with L. So L is going to go into the denominator this time. Okay, so that's step one, set up the equation. The second step, remember, is that we need to get K. So we've got to find the two numbers that go together so that we can find K. So of what's left, which two numbers happen at the same time? Well, looking here, let me change colors here. All right, 48 inches long and vibrates 256 times per second. So 48 and 256 are the two numbers that happen at the same time. So let's use those. So we need to figure out which one's V and which one's L. So 48 inches long, that one's going to have to be our length, L. And 256 times per second, that's going to be our V. Okay, so once we identify which one's V and which one's L, we can put them in here. All right, so we've got 256 equals K over 48. And on these, we're going to have a little bit of a fraction, but that's okay. Remember from our review sheet, how do we clear a fraction? We multiply by the denominator. Okay, so multiply on both sides by the denominator. On the right side, they're going to cancel out. And we've got 48 times 256, and that should give us 12,288. Okay, so our K is 12,288. That's kind of big, but that's okay. Let's go ahead and put that into our equation. And we're going to have V is equal to 12,288 over L. All right, so our first step was to set up the equation. Our second step was to get K. And now our last step is to answer the question. What is the length of string that vibrates 576 times per second? So 576 is going to be length or vibration? Okay, so look at it. That's going to be vibration, right? So they're giving us that V is 576, and we need to find L. So 576 equals 12,288 over L, and we need to solve for L. So just like before, we clear a denominator. So we multiply by L on both sides. So we've got 576L equals 12,288. And then we get L by itself by dividing by 576. All right, and that should come out to 21.3. And our length, if we go back to the question, our length is in inches. Okay, so our final answer is that length is 21.3 inches.